Alright, so this is a Chapter 3 review, and basically anytime you're sitting down to watch a review, it's way, way better if you've already done the entire review, checked your answers, and are just kind of watching this to make things kind of just sink in. But you shouldn't watch the review without having tried it. You should treat the review like it's a test, take it like it's a test, and kind of grade yourself to kind of sense how how well you understand the material. So hopefully you're not having to write much when I do the review here. So the first problem wants me to find x and y intercepts, and it doesn't really matter which one you do first. You're plugging in zeros to find the intercepts. If you plug in 0 for x, you get the y-intercept. If you plug in 0 for y, you get the x-intercept. And the nice thing about this problem is it wants me to graph. The graph's going to be a line. The intercepts, because they're going to be distinct points, it's going to make it real easy to graph the line. So first thing I do is plug in 0 for x. I could have done the x-intercept first, but I'm doing the y-intercept. The 2 times 0 is 0, so this left side kind of just zeroes itself out. It leaves me with minus 3y equals 18. And then when I divide both sides by minus 3, on the left side the minus 3's cancel, I'm left with the y. On the right side, a positive divided by a negative is a negative, and 18 divided by 3 is 6, so I'll get negative 6. So in for my answer, the y-intercept, I should write it as a point because it is a point on the graph, and points on the graph have both an x and a y. So I'm going to use x equal to 0, y equal to negative 6, and say it's the point 0, negative 6. I'll find the x-intercept next. I'll let y equal 0. I'll go 2x minus 3 times 0 equals 18. Because 3 times 0 is 0, this is really 2x minus 0 equal to 18. So the left side simplifies to 2x equals to 18. And then I'll divide by 2 to get x equal to 9. And in my answer for the x-intercept, I'm also going to write it as a point, and it's real easy to write it as a point because I know the x and the y. I'm going to choose y equal to 0, x equal to 9. I'm going to write that as the point 9, 0. On the test, you'll be given a blank graph if I want you to graph something, but I don't have graph paper available to me this morning because the campus computer network is not working. So I'll do a really crude graph, but something that's completely adequate. So to sketch the graph of this, I just really have to plot the intercepts and connect them with a line. As long as my x and my y intercepts are correct, because this is a line, 2 points are sufficient to make a correct graph. So I'm going to plot the y-intercept, which is the point 0, negative 6, the x-intercept, which is the point 9, 0, connect the two intercepts with a line, and it would be nice if I put arrows at the end of my line to signify that the graph keeps on going, that it doesn't stop. But if you don't put the arrows in, it hardly matters. I wouldn't take points off. I don't give you points for having the arrows, nor take points off if you don't have the arrows. So that's everything. I found the x-intercept, I found the y-intercept, and I sketched the graph. Part B of this is a little bit trickier, and probably not the kind of problem I'd put on the test. 1A is, if something from number 1 comes on the test, A is more likely than B. B, I'm just changed from last semester to this, and that should be the B that you see on your handout. So again, I'm going to find the x-intercept and the y-intercept. I'll do them in the opposite order this time because it doesn't matter. The first thing I'll do is I'll find the x-intercept. I do that by letting y equal to 0. So I'll go ahead and just do that. So I'll go 3x minus 5 times 0 equals to 0. The 5 times 0 turns into 0, so I get 3x minus 0 equal to 0. That's going to reduce to 3x equals to 0. And when I divide both sides by 3, on the left side the 3's cancel and I get just x. On the right side I have a fraction with 0 in the numerator, and any fraction with 0 in the numerator is equal to 0, and it's not an undefined. So I get x equal to 0. And in for my answer, what I'm going to write for the x-intercept is that's the point x equal to 0, y equal to 0. So I'm going to write 0, 0 for the x-intercept. That's the unfortunate case. If 0, 0 is the x-intercept, 0, 0 is also going to be the y-intercept. And then I only have one point on my graph, and I'm going to have to do something more to sketch the graph than just connect 2 points, because I only have 1 point. To find the y-intercept, I let x be 0. So I go 3 times 0 minus 5y equals to 0. The 3 times 0 piece turns into 0 minus 5y equals to 0. And that makes the left side simplify to minus 5y equal to 0. I'll divide both sides by negative 5. Oh, I don't know why I threw that extra line in there. On the left side, the y's cancel, the negative 5's cancel. I'm left with the y. On the right side, I have a fraction with 0 in the numerator, which is equal to 0. Again, I'm going to write the intercept as a point. It's x equal to 0, y equal to 0. I write x first, y second. I get the point 0, 0. I'd like to graph like I did the last problem, but the unfortunate thing is the point 0, 0 doesn't tell me enough to finish the graph. So I'm going to do the thing that we did in the videos, and I'm going to take the equation and solve it for y so I can use my slope. So I need to do extra because I only have 1 point. So I'm going to find the slope of the line to finish my graph. To find the slope of the line, I'm going to solve the equation for y, because once the equation of a line is solved for y, the number in front of the x is the slope. So I'm going to minus 3x from both sides and get minus 5y equals minus 3x. I could take on a plus 0, but I don't really need it. And then I'm going to divide by negative 5. On both sides, the two negatives cancel to be positive. On the left side, I'm left with just plain y. On the right side, I'm left with positive 3/5 x. And that tells me that the slope is 3/5, which tells me I need to go up 3 and right 5. So from the point 0, 0, I'm going to go up 1, 2, 3, and right 1, 2, 3, 4, 5. So up 3, right 1, 2, 3, 4, 5. I'm winding up at the point 5, 3. I could do it again if I had graph paper. I could go up 3 and right 5 again to get a more accurate graph, but since I don't have room, that's adequate to do it just once. I'm sure during my regular lectures I probably did it 2 or 3 times as up and over kind of strategy. But that would be a completely adequate graph, and that would complete problem part 1b, because the instructions said find the x and the y-intercept and sketch a graph, and I did all 3 things that I was supposed to do. Again, if I had to gamble, I doubt that I would give you a problem on a test where you had to find the slope to finish up a graph. And if there's a question that asks you to find the x-intercepts, y-intercepts, and sketch a graph, it'll probably be more like 1a. Part B is a tough problem. I'm definitely going to use my calculator for it. So the instructions write the slope-intercept form of the line, and this part of the instructions ask me to solve the equation for y. So the first thing I'm supposed to do based on the instructions is solve the equation for y. And then once I have the equation solved for y, I can do the rest of it. I could identify the slope and the y-intercept. The identify the slope and identify the y-intercept part of this don't require algebra. So in my answer, I'm going to have 3 things. My answer is going to have first an equation of a line, the slope-intercept form of the line. That's going to require algebra. And then after I get that equation, I'm going to write down what the slope is, and I'm going to write down what the y-intercept is. And the last two parts of this aren't going to require any algebra. It's just going to be looking at the equation. For the slope, I'm going to write m equals. For the y-intercept, I'm going to write 0 comma some number, because y-intercepts are points on the graph on the y-axis. They have x equal to 0, y equal to some number. For the slope-intercept form, I'm going to have y equals mx plus b. So there's three components to my answer. One's going to be in the form y equals mx plus b. So the left of the equal sign, I'm going to have a y. To the right of the equal sign, I'm going to have a number in front of an x, and then a number after the x. The number in front of the x I'm going to put in for the slope part of the answer. The number after the x I'm going to put is the non-zero part of the y-intercept. So the hard part is solving this equation for y because of the fractions. Not so hard because I have a nice calculator that will just rock these fractions. So to solve this for y, I'm going to minus 1/3 x from both sides. When I minus 1/3 x from the left side, it cancels out, but I still have the minus 2/3 y. On the right side, I have the minus 1/3 x and the plus 4 that are like terms that can't be combined together. To solve for y, I'm going to divide everything by minus 2/3, which is the same as multiplying by minus 3/2. I'm going to do these all on my calculator, but if I wanted to do this, I'd go minus 1/3 times minus 3/2, because dividing by minus 2/3 is the same as multiplying by minus 3/2. Then I'd go negative 1 times 3 is negative 3, is positive 3. 3 times 2 is 6. I'd get 3 over 6, which is 1/2. So I should get positive 1/2 when I do this division, but I don't have to be that clever. I can go fraction minus 1 over 3. Oh gosh, is that another fraction? I messed up. How about this? Fraction again, minus 1 over 3. So I had to hit the fraction button twice before I get started, and after I enter the negative 1/3, I hit my fraction button for a third time, and then I do the minus 2/3. And it's going to give me positive 1/2. So I'll do that again. I do fraction once, fraction twice, minus 1 over 3, get down to the denominator, fraction a third time, and then minus 2/3. And it tells me in front of the x I'm going to get a positive 1/2. To the left of the equal sign, the minus 2/3 cancel. Any number divided by itself is 1. So I get just the y. To the right of the equal sign, the first number I'm going to have is a 1/2 in front of the x. If I wanted to, in front of the 4, or where the 4 was, this is really 4 times negative 3/2, which is really 4 over 1 times negative 3/2, which is negative 12/2, which is negative 6. Because dividing by negative 2/3 is the same as multiplying by negative 3/2. I'm going to get a minus 6, and I'll do that in my calculator just in case you can't do it by hand. So I'm going to go fraction 4 over fraction minus 2 over 3, and I get a minus 6. And then I have my choice here. I can write plus negative 6 and put the negative 6 in a parentheses, or I can write just the minus 6. The minus 6 is the way we generally write it, but either one of these lines here would be acceptable for the slope-intercept form of my answer. I'm going to write 1/2 x minus 6 because that's the common way to write it. Usually you don't write plus a negative. So I'm done with the algebra part of number 2. I'm going to identify the slope. The slope is the number in front of the x when the equation solved for y, so the slope is 1/2. And I'm going to identify the y-intercept. The non-zero part of the y-intercept is the number after the x. In this case, it's the minus 6. So that's everything for number 2. I did the algebra to solve the equation for y. Writing it in slope-intercept form means solve the equation for y. And then I identified the slope and identified the y-intercept. And I wrote them nicely. I wrote an m next to the slope. I wrote the y-intercept as a point. Yuck. So, 3 wants me to find an equation in slope-intercept form. I know that the answer of my equation, my problem in part A, is going to be of the form y equals mx plus b, because I'm trying to find an equation of a line, with the m and the b changed to numbers that fit the problem. The nice thing about this is I already know the m. So in my answer, the number in front of the x, I'm going to make 2/5, because that's what the m is. The unfortunate thing is the b is not 2. B would be the y coordinate if the x coordinate is 0. Since the x coordinate of this point isn't 0, I have to do algebra to find the b. What I'm going to do is I'm going to pick x equal to -1, y equal to 2, m equal to 2/5, plug those three numbers into the y equals mx plus b formula, and then do the algebra to solve for b. So I'm going to go y equals to 2 equals to m, which is 2/5, times x, which is -1, plus b. I could multiply these in my head, but if you can't do the multiplication, to do fraction 2/5 times parentheses -1, you get -2/5, and that negative could be written in front of the fraction or in the numerator, it doesn't matter. So doing the multiplication to simplify the right hand side, I get 2 equals -2/5 plus b. My goal is to solve for b, so I'm going to add 2/5 to both sides. With my calculator, it's easy to do the left side. 2 plus 2/5, I just go 2 plus fraction 2/5. My calculator tells me that it's 12/5. So I get 12/5 equal to b. Without my fractions, to do the 2 plus 2/5, it's not hard, but it's not maybe obvious. If I wanted to add without a calculator 2 plus 2/5, I'd write the 2 as 2/1. And then I'd multiply it by 5/5. So I'd say this is 10/5 plus 2/5, and I'd still get my 12/5. So I'm ready to finish up my answer. I already changed the m in the y equals mx plus b formula with the number that fits this problem. Now I need to change the b with the number that fits this problem, and I'm going to put a 12/5 in for the b. And that's everything for part A of number 3. Part B, my goal again is to write an answer in the form y equals mx plus b with the m and the b changed to have numbers that fit the problem. And same sort of deal here. I know I'm in the formula y equals mx plus b, I'm going to replace the m equal to 0 in my answer, because I'm told the slope is 0. Now I have to find the b, because I'm not really, well, it's actually given to me, but it's not. I'll do the algebra anyways. So now I'm going to find the b, because points that don't have 0 as the x, they aren't always b's. They're in fact rarely b's. So I'm going to find my b by letting m equal to 0, x equal to 1/4, and y equal to -3/5. I'm going to take those three numbers just like I did in the last problem and plug them into the equation y equals mx plus b. So for the y, I'm going to go -3/5. For the m, I'm going to plug in a 0. For the x, I'm going to plug in 1/4, and I'll leave the plus b alone. The nice thing about this is there's really no algebra to do, because this 0 times 1/4 comes out to 0. So you get -3/5 equals 0 plus b, and 0 plus b is just b. So I'm going to replace the m with 0, and I'm going to replace the b with the -3/5 in my answer. So for my answer to part B, I have flexibility. I can say y equals 0x plus negative 3/5, or I can say y equals to 0x minus 3/5 if I didn't want to use the plus the negative sign. Or even better yet, I can just say y equals negative 3/5 because 0x cancels out. These are all correct answers. This is probably the best answer because it doesn't have extra writing. This is probably the second best because at least it doesn't have that double sign when you don't need it. And this is the, least desirable. I can't spell desirable, I don't think. Answer, but it's all correct. So any one of those three for an answer would be okay. The bottom one being the best, the top one being the least best. And but I don't care. I take any of those. Part C is the hardest because I don't have the M and I don't have the B. So I have to do computations to find each. So my goal again is to find a value for M and B and replace the M in the yx plus b formula and the b in the ym equals mx plus b formula with those numbers. Unfortunately, unlike the last two problems, I haven't given you the slope, so first I have to find the slope. To find the slope, because I have 2 points, I'm going to use the formula y coordinate of the second point minus y coordinate of the first point over x coordinate of the second point minus x coordinate of the first point. If you don't trust yourself, you could use your calculator. Go minus 7 minus a negative 1 over 6 minus 4. And I get negative 3 for the slope. If I wanted to do this by hand, this is minus 7 plus 1 over 2. Change the double negative to a positive. 6 minus 4 is 2. The numerator comes out to negative 6. Because the 7 and the 1 have opposite signs, I have to subtract them. And minus 6 over 2 is minus 3. So in my answer, I'm going to plug a minus 3 in front of the x. Once I find the m, I could find the b. And to find the b, I could go x equal to 4, y equal to negative 1, m equal to negative 3 in the y equals mx plus b formula. Or I can do x equal to 6, y equal to negative 7, m equal to negative 3. I'll show you they both work. So I'm going to go y equals m x plus b, or y equals m x plus b. Both computations, regardless of the point that you pick, are going to give the same value for b for my answer. Using the first point in the equation y equals mx plus b, you get minus 1 equals minus 12 plus b. You add 12 to both sides. The 1 and the 12 have opposite signs, so I have to subtract and take the sign of the larger. I get a positive 11. The other version, using the second point, you get minus 7 equals minus 18 plus b. And you have to add 18 to both sides. Minus 7 and 18 have opposite signs, so I have to subtract and take the sign of the larger, and I get 11. On the right side, the 18s cancel, and I get my b. So in my answer, I'm going to replace the b with a positive 11. So I get y equals minus 3x plus 11 for my answer. That's the last one in that problem, I think. So the problem 4's finding the domain in a range from a graph, you have to figure out whether your answer needs to be in set notation, whether the graph needs to be extended or not. It would be completely wrong. It would be an absolutely no points if for the domain you wrote negative 1, 0, 1, 3, and 4, and you just plucked off the x coordinates of the points. Even though I labeled 5 points, this graph has infinitely many points because the points are connected. when the points are connected, I leave them connected, and I ask myself if the graph needs to be extended or not. Because there's periods at each end, the graph doesn't need to be extended. I can live with the points just how they are. To find the domain, I need to find the x-coordinate of the most left point and the x-coordinate of the most right point. And once I've identified the point that's most left on the graph, the most right on the graph, the domain is just those x values, usually separated by a comma, usually in square brackets unless one of them has an infinity. To do the range, I have to be able to identify the bottom point and its y, and the top point and its y. The point 1, -4 is at the bottom of this graph. Its y coordinate is -4. The point 4, 5 is at the top of the graph. Its y coordinate is 5. I would say the range is -4 to 5. So for A, the graph didn't need to be extended because there were periods at each of the endpoints. It's wrong to write a domain in set notation when the points are connected. When the points of the graph are connected, you have to use interval notation for your domain and your range. Part B, there's a distractor point. The point 7, 2 has nothing to do with the domain or the range, actually. But this graph doesn't need to be extended on the left end, but it does the right. So the graph needs to be extended up and to the right forever, to the far right edge of the x-axis, which is the positive x direction, and to the top of the y-axis, which is the positive y direction. So this graph needed to partially be extended. Only one half of the graph needed to be extended. This point 7, 2 has nothing to do with the domain or the range because it's not at the bottom of the graph, it's not at the top of the graph, it's not at the left or the right edge. To do the domain of this, I need to find the most left point and its x, and I need to find the most right point and its x. So the domain for this problem, the most left point is the point 3, 0. Its x is 3. The most right point is a double infinity. Its x is infinity. Usually, points on the graph, when we show them in the domains in interval notation, get square brackets. Points that I extend the graph to the infinities usually get round brackets. So this would be the best answer. For the range, I need to identify the bottom point and its y, and the top point and its y. For the range, I'm going to pick off the y coordinate of the bottom point, which is 0, the y coordinate of the top point, which is infinity. Again, points on the graph generally get square brackets, and infinities generally get round brackets. I don't know that I've ever taken a point off for a student putting a square bracket as opposed to a round bracket in intermediate algebra. In college algebra or higher, I might get a little pickier. In 4C, because the points aren't connected, it would be wrong to connect the points. You leave them unconnected, and for the domain, you just take the x-coordinate of each point, and for the range, you take the y-coordinate of each point. So when I go to do 4C, I know that my domain and my range are going to be in the squiggly set brackets. And that happens anytime you're given a graph that has distinct points that aren't connected with some sort of line. So for the domain, I'll pluck off the x's of -3, 3, and 7. Doesn't matter the order that you write those in, just as long as you have those numbers. And for the range, I'm going to pluck off the y-coordinates of 0, 2, and 4, and it doesn't matter the order that you write the 0, 2, and 4 in. If your range has the numbers 0, 2, and 4, then we're completely okay. And that's all there is for 4C. So now I'm going to... Was that ready? 4C or was that 3C? That was 4. Oh, yeah, absolutely was. Now I'll move on to question 5. In question 5 wanted me to refer to this graph, so I brought it back up. And question 5 is going to have no algebra because there's no equation. So I have to understand what the questions, which each part of the question is asking me to do. And none of them are terribly hard. Part A, the number that's given is in a parentheses, so it stands for an x. And part A is asking me to find the y that corresponds to the x equal -1. So part A, the -1 that's given is the -1 that's an x coordinate of the point. It's that -1. And for an answer to part A, I can say f of -1 equal to 0. Or if I want to, I could say y equal to 0. For part B, because the number that's given is to the right of the equal sign, then that number stands for a y value, and I'm asked to find an x value. And the x value that corresponds to 5 is 4. For part B, if I want to, I can say f of 4 equals to 5, or I can say x equal to 4. So you could physically put the 4 in for the x, you can physically put the y to the right of the equal sign. Part C wants me to find intercepts. Intercepts are points on the axes, and for part C, to find the x-intercept, I look at the x-axis, and this is the x-axis. Any point on the x-axis is considered an x-intercept. So in part C, for the x-intercept, I'm going to say it's the point -1, 0, and the point 3, 0. For the y-intercept, I look at the y-axis, and when I go to the y-axis and find a point, the point on the y-axis is 0, -3. So for the y-intercept, I'm going to say it's the point 0, -3. So none of the parts of number 5 require any algebra. Intercepts are points on the axes, and the part A and the part B, you just have to understand if the number given is an x or a y. If it's inside a parentheses, it's an x. If it's to the right of the equal sign, it's a y. Because I always can change a function name to y. This is like saying y equals to 5. So, I can live with this. I'm going to leave myself a lot of room here. And okay, that's fine. So for problem 6, it gives me a function called f, h, and g, and it wants me to do a few things. The d is a hard part, but to do f of -3, I go to the f function, I change the x to -3. So the answer to part A of number 6 is whatever that equals to. It's not x equal to whatever, because x is -3. My answer shouldn't say x equal. So when I do 3 times -3 plus 4, my answer is -5. It's actually a y that I'm getting. I'm plugging in -3 for x and getting -5 for y. So my answer, I can write f of -3 equals -5, or I can say y equal to -5, because the algebra here, the orders of operations would lead me to that, because you do multiplication first, these numbers have opposite signs, you subtract to take the sign of the larger. Because the number I'm finding is to the right of an equal sign, it stands for a y. These are absolute value signs in problems for the h function. H wants me to find the absolute value of 4 plus 1. I don't think we've done absolute value this semester, but it's something that you should be familiar with. The absolute value of a negative number just takes the negative sign and makes it positive. The absolute value of a positive number is just the number inside the absolute value. So the absolute value of 5 is just 5. It's just, if this was a -5, it would be 5. The absolute value of a number is that number if it's positive. It's that number made positive if it's negative. So for my answer, I can write h of 4 equals 5, or I can write y equals 5. For I don't know how to do absolute value on my calculator, so I'm sure it does it. I just don't know where it's hidden at, so I can't do that for you on my calculator. For C, I'm going to use the g function and change the x to -2. I'm going to go -2 squared minus 3. When you're squaring a negative, the 2 has to be outside the parentheses. If I wanted to do this on my calculator, I'd go -2 squared minus 3. If I had the negative, if I had the 2 inside the parentheses, my calculator would give me the wrong answer, and I get 1 for what my answer should be. If I was doing this by hand, -2 squared is -2 times -2, which is +4, and then 4 minus 3 is 1. So for my answer, I can say g of -2 equals to 1, or I can say y equal to 1. It wouldn't be right to say x equal to 1 because x is -2. The last one's a little bit cruel. I'm going to do it up here because it's going to take some room. Just like I did g of -2, to do g of x plus 2, you need to change the x to that x plus 2, square it and subtract 3. To do x plus 2 squared, it's a foiling problem. I'm going to do x plus 2 squared by expanding the parentheses so I don't see the exponent anymore. And now I'm going to FOIL. Firsts are x times x, which are x squared. Outers are x times 2, which is a positive 2x. Inners are 2 times x, which is a positive 2x. Lasts are 2 times 2, which is a positive 4. So that's the x plus 2 squared part. The minus 3 doesn't change when you're doing the foiling, but it doesn't go away either. I'm almost ready to have my answer. I'm just going to combine like terms. If this factors, I'll factor. If it doesn't factor, I'll be done. So the x squared is going to stay alone. The 2x and the 2x are going to combine to 4x, and 4 minus 3 are going to come to a plus 1. If you try to factor this, you'd make 2 parentheses. The lasts have to multiply to 1 and add to 4, and there's no numbers that I could put in for the lasts that would add up to 4. The only choices would be 1 and 1. So for an answer, I can say g of x plus 2 equals x squared plus 4x plus 1, or I can say y equals 2x squared plus 4x plus 1. Since it doesn't factor, I can't factor it, and there isn't, and even if it did factor, I'd factor and I'd stop. There wouldn't be more to do than that. Okay. 7 gives me a function called f that's written as a set of points. Has 4 questions, none of which require any algebra because the f function doesn't have any x's or any symbols in it. So to find the domain of f, because it's written as 4 points, the x coordinates of the 4 points written in any order would be adequate for the domain. If you took the time to write it in ascending order, it probably would be nicer. So for part A, had you written the domain as -6, -2, 1, 4, because you like numbers going from smallest to largest, it's probably nicer to look at, but it doesn't make it more or less correct. To do the range of this function, because it's written as a set of points, the range is just the y coordinates of each of the points. It's redundant to write the -2 twice, so it would be okay if you just physically wrote each of the 4 y's down. It would be better if you didn't write the -2 twice, and if you wrote the numbers in ascending order. So again, these are both correct answers for the domain, and these are both correct answers for the range. It's just a matter kind of in some sense of personal preference. These are better answers probably because the numbers are written in ascending order. I don't have any duplications. Part C gives me function notation, and it gives me the 1. Because the 1's written to the right of an equal sign, it stands for a y value. So the 1 that's given in part C, being to the right of an equal sign, it stands for a y. It wants me to find the x that corresponds to that, and the answer is going to be -2. And for my answer, I can write f of negative 2 equals to 1, or I can get rid of the function notation completely and just say x equal to negative 2. Part D, the number 4, because it's in a parentheses, stands for an x value. It wants me to find the corresponding y value. And for my answer, I can say f of 4 equals to negative 2, or if I want to not use the function notation, I could just say that's a y equal to negative 2. So again, there's another bank of problems that didn't have any algebra, and there's a lot of that on this test. As I start to go through the review, problem 1 had algebra, 2 had algebra, all parts of 3 had algebra, but none of the 3 parts of 4 had algebra. So there were 3 problems on the review without algebra. 5 had 3 parts, none of them had algebra. 6 had algebra. 7 had 4 parts, none of them had algebra. So there's a lot of problems that don't have algebra, and every one of those problems that doesn't have algebra is probably going to make it onto the test, and it's real hard for me to give you partial credit on a problem that doesn't have algebra. Your answer is either right or wrong. And so if I have 10 parts of questions or 11 parts of questions worth 4 points each that don't have algebra, that's like half the test. That's probably 45 points or so of the test could be gotten by just knowing the proper way to dig out an answer. Question 8 asks me to find a domain of a fraction. To find a domain of a fraction, you ignore the numerator. So in part A, I'm going to ignore the x plus 2, and I'm going to solve the denominator equal to 0. To find the domain of any fraction, I ignore the numerator. I find out where the denominator equals to 0, and I write my answer. I'd live with an answer in words even though it doesn't ask for it. For part A, it would be completely fine by me if you said the domain is all real numbers except 3. Because it asks for interval notation, I'll show you how to do that. To do an interval notation answer, you start off with a number line and you put negative infinity on the far left edge, positive infinity on the far right edge, the number that you're excluding written between the infinities, and you form round brackets. So in interval notation, and that's technically what's asked for, all round parentheses in domains of fractions, the domain would be negative infinity to 3, union 3 to infinity. Part B of number 8 is also finding the domain of a fraction. To find the domain of a fraction, you always ignore the numerator. The numerator gives you an x-intercept if you set it equal to 0, but it has nothing to do. Such a bad problem. I'm going to change this problem to p plus 4 over, just because if you factored and canceled, it would cancel out. So when you print yours out, it's going to say p plus 4 as opposed to p minus 1. The p minus 1, it was probably not the best thing to have there, because there's some domain things going on there that are confusing probably. So anyways, I changed part B to h of p equals p plus 4 over p squared plus 2p minus 3, just for my peace of mind. The algebra would be the same. You'd still ignore the numerator and you'd solve the denominator equal to 0. That's the correct way to find the domain of any fraction. But if you factored and canceled, and then there might be some confusion there. So I'm deleting that possibility. So because the denominator has a square, when I set it equal to 0, I'm going to have to factor. This is easy factoring. I don't have a number in front of the p squared, so I don't need bottoms up. My signs have to be plus and minus. I have to multiply to 3, subtract to 2. It's going to be 3 minus 1. Once I get the problem factored and set equal to 0, I'll split each factor up The p plus 3, I'm going to minus 3 from both sides and get minus 3. The p minus 1, I add 1 to both sides and get positive 1. It would be completely fine if you wrote the domain is all real numbers except negative 3 and 1. But if you want to do the interval notation, because that's what the instructions ask for, and if you go on to Math 151 or 187, your teacher might make a big deal out of this. So to get the answer in interval notation, I create a number line that has negative infinity on the far left, positive infinity on the far right, the numbers that I'm excluding from the domain written in order between the infinities, and then make parentheses to capture each of the segments. In interval notation, the domain would be the interval from negative infinity to negative 3, union the interval from negative 3 to 1, union the interval from 1 to infinity, round brackets around all the numbers because we're excluding those numbers from the domain, and round brackets exclude a number from the domain. Even though between 8 and 9, 8's the harder question, to find the domain of a fraction is harder than finding the domain of a polynomial. 8's not the question that a lot of students miss on the test. If I give a question that gives a fraction, I ask you to find the domain. It's easier than 9. 9, each of the parts of number 9, each of the functions is a polynomial. Because it's not a fraction and it's a polynomial, there's no algebra to do for each of the domains. If you do any algebra, then what you're likely finding is an x-intercept. And an x-intercept often has nothing to do with the domain. So for each one of these, parts A and part B, there's no algebra. In words, for part A, the domain would be all real numbers without an except. Or if you want to do interval notation, it'd be the interval between negative and positive infinity. Similarly, part B, if you did any algebra, you'd probably wind up getting a 3 in your answer, and that would be an x-intercept, which would have nothing to do with the domain of this. Because this is a polynomial, there's no algebra necessary to find the domain. You can either say the domain is all real numbers, if you want to use the word strategy, or if you want to do the interval notation, you could use the interval from negative to positive infinity. This is probably the most missed problem. I put finding the domain of a polynomial every semester on my chapter 3 test, and out of the 28 or so students that will be taking the test, I don't know, 12 students will get it wrong, and it's supposed to be a freebie. And it's the kind of wrong where if you do any algebra, if it's a 4 or 5 point question, you won't get any partial credit. So it's important to be able to differentiate the finding the domains of functions written as equations. Fractions, there's algebra to do. You ignore the numerator, you set the denominator equal to 0. Polynomials, which means at this point they're just not fractions. They have domains of all real numbers, and there's no algebra to do. Yuck. 10 is a little bit harder. At least part A is harder than I'd probably write on a test, but it's not unfair. So to find the x and the y intercepts, first you change the function symbol to the letter y, because it makes it easier. So for problem 10a, I'm going to change this to y equals to 3x squared plus 4x minus 4, and then I'm going to find the intercept. The y-intercept is way easier. For the y-intercept part of this, because I'm supposed to find the x and the y-intercept, you let x be 0. And to do this in the y equation, I'm going to go y equals to 3 times 0 squared plus 4 times 0 minus 4. All the 0 pieces 0 out and you get minus 4. I could do this on my calculator easy enough. I can go 3 times 0 squared plus 4 times 0 minus 4. My calculator tells me that that's minus 4 because this is really y equal to 0 plus 0 minus 4. And that gives me minus 4. That's the easy part. So in part 10a, if I go to write down my y-intercept, there's just one of them. It's going to be the point 0, negative 4 because I plugged in 0 for x and got negative 4 for y. The hard part of this is the x-intercept. To do the x-intercept, you let y equal to 0. So here I'm going to go 0 for y equals to 3x squared plus 4x minus 4. Stuck with bottoms up factoring. There's a square and it's set equal to 0, so I need to factor. So I'm going to multiply. Go x squared plus 4x minus 12. Bottoms up is multiply, then factor. That factors into x plus 6 times x minus 2. Then divide, reduce, and bottoms up. First fraction, x plus 6 over 3, gives me an x plus 2. Second fraction, x minus 2/3, gives me a 3x minus 2. So I've done the hard part, the bottom-up factoring part, but I haven't got my x-intercepts ready to write in an answer yet. Now that I have it factored and set equal to 0, I split each of the factors up, separate them, set each one equal to 0. For the x plus 2 factor, I'll minus 2 and get x equal negative 2 for the non-zero part of the x-intercept. For the 3x minus 2 factor, I'm going to add 2 and then divide by 3. I'll get x equal to 2/3. Now I'm ready to finish up my answer. So the first x-intercept I got had x equal negative 2. I let y equal 0, so it's the point negative 2, 0. The second, I plugged in 0 for y and got 2/3 for x, so it's the point 2/3, 0. That's the harder of the problems for part 10. For part B of 10, I'm going to start off and I'm going to change the h of x to a y. It just makes it easier for me. You don't really absolutely have to do that, but for me it just makes it a lot easier. The function notation's kind of cumbersome when it comes to these computations. So the y-intercept is easier. For the y-intercept, I'm going to let x be 0. If you don't use your calculator, you might mess this up. So I'm going to do this on my calculator, then tell you why my calculator gives me 0. So on my calculator, the y-intercept, I'd go 3 times 0, and then 2 times 0 minus 6, and then 0 plus 1. And when I hit enter, it gives me 0 and not negative 6. If I did each of the parentheses, the first parentheses you get 0 minus 6, which is a negative 6. Second parentheses you get 0 plus 1, which is 1. It's real common for students to write negative 18 because they forget when you multiply, if there's a 0 in any multiplication string, you get 0. And they just ignore the 0 and treat it like it's a 1 and get negative 18. That's wrong. Here you should get 0. So when I go to write my answer to this, the y-intercept, I plugged in 0 for x and got 0 for y. So it should be the point 0, 0. To do the x-intercept, there's actually going to be 3 of them. To do the x-intercept, you let y be 0. So I'm going to go 0 equals to 3x times 2x minus 6 times x plus 1. Because this is factored and set equal to 0, I don't multiply it out. I just take each of the three factors and set each one separately equal to 0. So I'm going to go 3x equal to 0, 2x minus 6 equal to 0, and x plus 1 equal to 0. For the 3x equal to 0, I just divide both sides by 3. I have a fraction with a 0 in the numerator, and any fraction with a 0 in the numerator is equal to 0. For the 2x minus 6 part of this, I add 6 to both sides and get 2x equals to 6. And then I divide both sides by 2 and get x equal to 3. And for the x plus 1 part of it, I minus 1 from both sides and get x equal to minus 1. So I'm going to write 3 x-intercepts. The x values are 0, 3, and negative 1, and each one has a y value of 0. So I'm going to write 0, 0, 3, 0, and negative 1, 0 for my 3 x-intercepts. That's also a really missed problem. A lot of times I sneak the problem just like 10b on the test, and a lot of times students will blow the y-intercept because they don't catch that they would write negative 18 if this was a question. And then they want to destroy this factoring by multiplying it out when they find the x-intercept, and that's not a good thing to do. It's been a really long time since I've asked a question like number 11 on the Chapter 3 test. I'm going to extend this table. So the chances of you getting this are very slim. And then your table will be extended. I just decided to extend it. So to fill in the table, I have x values. I want to get corresponding y values. F of x and y are interchangeable. What I'm going to do is do f of negative 2. Plugging that in, I get negative 2 squared minus 3. I don't need my calculator to do that, but I could use my calculator. So negative 2 squared minus 3. It's going to be 4 minus 3, which is 1. I'm just filling the whole table, then I'm going to do my graph. F of negative 1 is going to be negative 1 squared minus 3, which is going to be negative 2. So negative 1 squared minus 3, which is negative 2. Then I'll do f of 0, which is 0 squared minus 3, which is going to be 0. Which is going to be minus 3. Luckily, I used my calculator. Then I'll do f of 1, which is going to be 1 squared minus 3. And that's going to be negative 2. And then I'll do f of 2, which is going to be 2 squared minus 3, which should be 1. But I'm fading on myself, so I'm going to use my calculator. Now I'm just going to plot those 5 points and connect them with whatever looks like they connect. They actually connect with something that's called a parabola. It's kind of the shape of a U. So I'm going to plot the points the best I can. First point I'll plot is point negative 2, negative 1. So I go left 2, down 1. And then negative 1, negative 2, left 1, down 2. Then the point 0, negative 3. And then 1, negative 2. And 2, negative 1. It might almost look like things are going to form a V. It should actually be more curved than it is a V, but we haven't graphed enough for you to really know that it's supposed to be more of a U shape. We do a ton of graphs like this in Chapter 5, and you'll get really good at graphing when you have an x squared, and you'll know that the shape is more of a U than a V. But as long as you got the points right and plotted them, if you connected them with a V on your review, that I can live with that, because it might not be clear unless you're using graph paper really what the shape should be. But this is rarely on the test, so I probably wouldn't worry about that so much. So So the last styles of problems from the last section. First, number 12 just wants me to create an equation. When I see the word directly, I know I need to multiply. When I see the word jointly, I know I need to multiply. The only word that I might see that tells me divide is inversely. So the three words that I'm worried about looking for are the words directly, jointly, and inversely. Problem 12 just wants me to create an equation that doesn't have any numbers, so I can't solve for k. So I'm just going to create an equation. Because I see varies directly, the first letter I'm going to write is a p, then I make an equal sign. I know I need a k for all these problems, and to the right of my k, it has to be multiplication because it's directly, and I have to have something that represents the square of x, and the square of x is an x with an exponent, not a radical sign, as opposed to square root. If it had said, it didn't, but if it had said the square root, that's the time I would have that symbol. But because the word root wasn't after x, I knew I needed an exponent. That's all there was to do for 12a. 12b, same style of problem. I'm just going to come up with an equation. There's no numbers to plug in for the letters. The first letter I see, I write it followed by an equal sign, and then I need the letter k. Because I don't see the word inversely anywhere, I know I just have to have straight multiplication. And jointly implies there's going to be two letters after the k as opposed to one, like directly. The letters I'm going to have are something to represent x and the square of w. Because there's no words before the x to tell me that it needs an exponent, I'm just going to leave the x alone. But the w, because of the word square before it, I have to put an exponent on with the w. And that's all there would be to do for number 12. 13 wants me to do the extra step and solve for k. So they're going to be two-step problems. My answer for both part A and part B is just going to be whatever k equals. So the first thing I'm going to do is create an equation with a k and the other letters in the problem. For part A, because I don't see the word inversely, I know I need multiply. And because there's no words before the x, I don't need an exponent or a radical. So first step, I do y varies directly as x. That's just a clean equation, y equals k times x. Now I'm going to plug the numbers in. I'm going to plug negative 12 in for y and 2 in for x. So I get negative 12 equals k times 2. I'm going to solve for k by dividing both sides by 2. On the left side, negative 12 over 2, I don't need my calculator for, but if you use your calculator, it's okay. On the right side, the 2's cancel and you're left with a k. So the answer to part A of 13 is negative 6. Part B is the first time I see inversely. Inversely, I know I need a fraction with a k in the numerator. The first letter I see in the problem is p, so I write it followed by an equal sign. I form a fraction with a k in the numerator because it says varies inversely. The letter that goes in the denominator is a q, and it doesn't need an exponent or a radical sign because there aren't any words like before the q saying like square, cube, square root, or cube root. So I'm just going to throw a q in the denominator. When I solve for k, I'm going to wind up cross multiplying. So in for q, I'm going to plug in 8. In for p, I'm going to plug in 3. So I'm going to get 3 equals to k over 8. I like to cross multiply, so I'm going to change it to 3 over 1 equals k over 8. I can multiply up and down. When I multiply up, I get 1 times k. When I multiply down, I get 3 times 8. 1 times k is just k. 3 times 8 is 24. So my answer to part B is k equal to 24. The last two problems are the three-step problems. First, I'll create an equation with a k. Then I'll use the numbers in the second sentence to solve for k. Then I'll use the information in the last sentence to answer my question. So 14, I scan the problem quickly. In the first sentence, I see varies jointly. which means I don't need a fraction. I'm going to need multiplication, 2 letters after the k. As I read through this problem, the first letter I see is a C. It stands for the costs. It's going to go to the left of an equal sign. And then I'm going to have a k. Because it's jointly, I need 2 numbers or 2 letters after the k. One that stands for the number of trucks, one that stands for the number of hours. The letters I need after the k are T and H. Straight multiplication because it's jointly. And I don't need any exponents or radical signs because I don't see any words like squares or square roots. So after the k, I'm going to have the letter T and the letter H. That takes care of the first sentence. Now I'm going to move into the second sentence. The second sentence, I have 4 trucks, so I'm going to plug in 4 for a T. I have 6 hours each, so that I'm going to plug a 6 in for the H. The costs are $1,800. I'm going to plug in $1,800 for a C. I'm going to leave the k alone. So I have 1,800 equals k times 4 times 6. On the right side, I'm going to multiply the 4 and the 6 and get 24. This gives me 1,800 equals 24k. And I'm going to divide both sides by 24. So I get 1,800 over 24 equals the k, which is 75. I'm not done yet. I'm only finished with the second sentence. So I did first sentence, second sentence. Now I'm going to go to the third sentence. Find the costs of using 10 trucks for 12 hours each. So I'm going to use my formula, finding the cost. In for k, I'm going to plug 75. In for trucks, I'm going to plug in 10. In for hours, I'm going to plug 12. And I'm just going to use my calculator and go 75 times 10 times 12 and get $9,000. So my cost, which is the C, is going to be $9,000 to use 10 trucks for 12 hours. 15 is the last problem, I believe. It's a 3-step problem. Look at the first sentence. I look for the key word. Directly means it's multiplying and only 1 letter after the k. The first letter I see stands for the interest. The second letter I see is for the amount of the investment. And so my formula, the first letter I see is going to go first, followed by an equal sign and then a k. And then to the right of the equal sign, I need something that doesn't have an exponent because there aren't any words that imply I need an exponent or a radical sign. So the first sentence is going to give me that equation. Now I'm going to use the numbers in the second sentence. $1,000 is the amount of the investment. So I'm going to plug 1,000 in for A. $75 is the amount of the interest. I'm going to plug that in for I. I'm going to solve this for K to finish up the second sentence by dividing both sides by 1,000. My calculator is going to give me a fraction, but I can live with that. 75 over 1,000. I get 3 over 40 equals to K. If you wanted to, you could make that 0.075 and it would work just as well. But I can live with 3 over 40. So first sentence gave me equation with a K. Second sentence gave me some numbers, the ability to solve for K. Third question gives me another number. It's the amount of the investment. I'll plug it in for A. And I'm also going to plug in 340. 340 is for K. So I'm going to go the amount of the interest equals K, which is 3/40, times the amount of the investment, which is $5,000. I'll just do this on my calculator. So I'm going to go fraction 3 over 40 times 5,000. That's going to tell me the amount of interest, and I get $375. So it's going to be $375 I equals what in interest. So theoretically, anything on the review is test worthy. This review, probably the graphing problem, the x squared minus 3 graphing problem, is something that isn't likely on the test. And the second part of number 1, where you had to find the slope before you could get the graph finished, that probably wouldn't be on the test. But most everything here is going to be on the test. There was a bottoms-up factoring that I just did recently. I usually don't put a lot of bottoms-up factorings on the test, I might have that same style of question, find the x and the y intercepts in something that needs factoring, but the factoring might not be bottoms up. But guaranteed, if you have this review mastered, there shouldn't be anything on the test that is surprising. I never try to make my test that different from the reviews, and I usually try to make my test a little easier than the reviews.